Chapter 16, Nuclear Chemistry, Section 6.16.1, Natural Radioactivity. So we're going to be talking about radioisotopes, which a radioisotope is just a regular old isotope, but it's one that emits radiation. Okay, radiation, small particles of energy. Right? And it does that, here's this theme again, in order to become more stable. So more stable, lower energy, all those themes that we've seen throughout the series here. Right? So just what are some general characteristics? Generally, above atomic number 19, there are one or more radioactive isotopes that exist. Right? And what we're really looking at here is the nucleus. All right? So, you know, what's going on? Well, there's this great repulsion in that nucleus between all these protons, and that's what's causing this radioactive material to be emitted. Right? So, like we said, they become more stable. How do they do that? Well, they give off different types of particles. There's alpha particles, beta particles, positrons, gamma rays. There's other types of particles as well. And what we're doing now is we are changing the protons. So now, all the way up until this chapter, it's been all about what are the electrons doing, what's happening when these two atoms come together with the electrons, what happens if we transfer an electron, what happens if we exchange atoms. Now we're looking at the nucleus. So that's of course why it's called nuclear chemistry. And this is the only time that we are going to change elements. So in other words, we're going to make brand new elements that weren't originally there. All right, let's refresh our memory on an isotope. We have the mass number, which is the number of protons and neutrons. We have the atomic number, which is the number of protons. And then, of course, the symbol of the element. All right? So here are just some examples of stable isotopes, and then their radioactive isotopes. All right? So what types of radiation can we actually give off? Well, we can give off an alpha particle, which is really a helium nucleus. So it's just the nucleus. A lot of times you'll see it with a 2 positive charge because it is just the nucleus. Now this thing is huge, right? So this is a very big particle. There is a beta particle. Oh, yeah, and that's the symbol for alpha. Here's the symbol for beta. A beta particle is basically an electron. Okay, so quite a bit smaller than the helium nucleus. All right. So here's an example of a beta particle. We can have a positron, which is a beta particle antimatter. Yes, antimatter is real. And if a positron and a beta particle collide, it's an annihilation reaction. They're gone. So the beta particle is the 0 over positive 1e. Looks a lot like, or pardon me, the positron is the 0 over positive 1e. Looks a lot like the beta particle. And then there is the gamma ray. Okay? Gamma rays are just pure energy, and they're rare by themselves. They usually accompany other decay reactions. And they do this in order, again, to become more stable, lower energy. So again, there are the different types of radiation that we can have. Okay, protons we've already talked about. Of course, you know the neutron. So going along with this, we often think of radiation as a means to combat cancer. And so why is it that we use radiation? Why do we use these radioactive particles? There are some cells that when they undergo rapid division, which is basically cancer is when you cannot control that rapid division of the cells. And so some of them are more sensitive to radiation. Bone marrow. What we're going to see are areas where we are constantly regenerating cells, right? So bone marrow, we're constantly regenerating cells. Skin, constantly. Reproductive organs, constantly regenerating cells. Intestinal lining. Children's cells, unfortunately. These are always constantly dividing and regenerating these cells. And so what happens is that the radiation will strike those molecules and actually knock off electrons, and that will form unstable ions. For instance, in the body, it'll form the ionized form of water. Well, as I said, cancer cells also undergo this rapid division, which is why we use radioactive particles on them. Different types of radioactive particles have varying penetrating abilities. Right? So alpha particle, I said the alpha particle is the largest particle. It's also the easiest to block. You can basically block the alpha particle with a piece of paper. Why? Because it's so large. So here's, imagine that here is a piece of paper, and it has all these molecules that are all lining up, and they sort of form like this. Well, the alpha particle is so big it can't fit between any of these holes. And so the paper is just going to stop it. Right? But the alpha particle does the most damage if it's ingested for the exact same reason, because now the alpha particle can't escape. All right? Beta particle, a little bit smaller, a little bit faster. Now we can start to penetrate into the body, but basically you can block it with heavy clothing. So again, not a major concern. Now, the most dangerous is the gamma ray. Right? So the gamma ray is going to possibly pass straight through body tissue, and that's bad news, especially when it's able to knock off atoms from your cells. All right? So this can be stopped by lead or concrete. So now we're talking about some much more dense material that we need. Okay? Think about the last X-ray that you had, and of course they used lead to protect the parts that weren't getting X-rayed. Right? Because lead is going to block everything, including gamma rays.